video, we are going to solve some examples under roasting, which is combustion. And in this case, we are going to take them, that's amount of air, weight of oxygen. So let's get going. So the first question is, we should calculate the minimum of air by weight required for a complete combustion of fuel having the following composition. So they gave us carbon to be 82%, hydrogen gas to be 13%, oxygen to be 3%. So as I told you, convert it by weight, and that is given to us also. But note, if this is not given to us, you can generate it by just dividing this by 100 and changing it to by weight. So now we are finding the minimum solution. So for the minimum of air by weight, we established that with that the formula is giving us 100 over 23 bracket open. We have 32 over 12 times the carbon composition, then plus 8 bracket open, the percentage of hydrogen minus, sorry, not the percentage of hydrogen. With this, there's no percentage here. Hydrogen minus oxygen composition over 8, you close bracket, plus sulfur, then you close the bracket. Look at this. This sometimes, and when you are dealing with this, you can get your answer wrong because of how you open your bracket and you do it on a calculator. So please, let's be careful with that. Yeah, me myself, I was having some issue with it. Yeah, so be careful. So with this, let's do some substitution. We have 100 over 23, then bracket open, we have 32 over 12, then times the composition of carbon, which is 0.82, then plus we have our 8, hydrogen is 0.13, then minus 0.03 over 8, then plus we have our sulfur to be 0, then you close the big bracket. So on your calculator, this is how you open it on your calculator. So let's do that. When you do that correctly, you are going to get for question number 1, you're going to get 13.9 kilograms of air. 13.9 kilograms of air. For the same question, if they ask us to find the volume of air, with the volume of air, minimum of air by volume, you are just going to change this to 100 over 21 and the same thing, and then you input it. Now please be careful. As I said, when inputting it on your calculator, you might be careful with the bracket, because this is affecting this is it, and this is that. Otherwise, when you don't do it correctly, you're going to have a wrong value. Let's go to the second question. For the second question, they're asking us that the percentage of composition of a sample of liquid fuel by weight is C is equal to 84.8% hydrogen. So let's put solution. Let's bring out the data. Carbon is 84.8%, which is also 0.848. We have our hydrogen to be hydrogen gas to be what? 15.2%, which is equal to 0.152 kilogram. And in this case, we are supposed to find the weight of air, right? Find the weight of air. So for the weight of air, what you need to do is that for the weight of air, we have our formula generated that it will be 100 over 23 bracket open, the percentage, that is 32 over 12 times the percentage of that's the composition of carbon by weight, plus 8 bracket open, the composition of hydrogen minus oxygen all over 8, then plus the sulfur, then you close the bracket. So in this case, when you do it, let's do the substitution. 100 over 23, and then bracket open 32 over 12 times, this is in kilogram, 0.848 plus 8 bracket open 0.152 minus oxygen is 0 over 8, then plus sulfur 2 is 0, then you close the bracket. So when you do that correctly, your weight of air needed will be, so you put this on your calculator, and when you do that, you're going to get 14.156 kilogram of air. Please, let's do that very correctly, because if you don't input it well on your calculator, as I said, you're going to have a different value. So please make sure the brackets are arranged in the way that I did it, and it's going to give you the correct answer. Let's move on to the third example. With the third example, is the question. A core of sample give the following analysis by weight. Carbon is 85%, hydrogen is 6%, oxygen is 6%. The remaining is being combusted. Determine the minimum weight of air per kilogram. Now let's pay attention to per kilogram. If they say per 2 kilogram, the answer that you get, you multiply it by 2. Per kilogram means per 1 kilogram. So that one you are going to multiply by 1, but we don't show it. So now let's do the data solution. Let's put down the data. Our carbon has 85%, and that will be 0.85 kilogram, comma. Our hydrogen is 6%, which will give you 0.06. Our oxygen is also 6%, which will also be 0.06. So then we do substitution. Weight of air, we have it to be 100 over 23. Then you open the bracket, 32 over 12 times the carbon mass, which is 0.85, then plus 8 bracket open 0.06 minus 0.06 all over 8, then you close it, plus sulfur here is 0, then you open it, you close the big bracket, because the 100 over 23 is affecting all. So in that case, this is 0. In that case, when you do that, we're going to have that our answer punching on the calculator. Let me punch it and see. When you punch on the calculator, right, you are going to get a value of 11.6811 kilogram. Let's see it to be 100 over 23, bracket open, then you bring a bracket, 32 over 12 times 0.85, then plus 8 bracket open, 0.06 minus 0.06 all over 8, then close the bracket, plus 0 bracket. We are going to get 11.6812 kilogram. Very simple as that. Let's move on to the last one, the last question. That's the fourth question. The last question is asking us to find a fuel has the following analysis. Carbon is 90%. We have our hydrogen to be 6%, sulfur to 2.5%, oxygen is 1%, ash is 0.5%. Calculate the quantity of air. So we want the weight of air required and the volume for complete combustion of 1 kilogram of fuel if 30 SS air is used. So we need to find it, right? So there's a if 30% of air is used, right? So I think this question is in two parts. We are finding the amount, the quantity of air. We are finding the volume of air. Then we will also find the volume of air if 30% excess of air is used, and also we'll find the volume of what, the weight of air if 30% of excess is used. Let's go. So the solution, right, I just generated this. For the solution, we need to convert it into what, this and this. So with this, please be careful of that. it's somehow tricky because when you are changing it to the mass, sometimes 1% you could do it 0.1, or 10% you could do it 0.01. So it's advisable to go over. So let's go to, so for the weight, the quantity of air, we know that the formula is going to give us 100 over 23 bracket open. We have 32 over 12 times 0.9, then plus 8 bracket open. We have hydrogen to be 0.06 minus oxygen is 0.01 all over what? 8, then plus the sulfur, which is 0.025. Then you close the bracket. Note, ash is not part, so we are not going to use ash in the calculation. So when you do that correctly and you take your calculator, for your answer, you're going to get 12.586 kilogram of air. Right. So for the quantity of air, we had 12.586 kilogram of air. But they say that if 30% excess of air is used, so let's do that. For 30% of excess of air, what you do now is that we have this to be the quantity of air. So we find 30% of this air. So 30% excess of air. So that means we're going to have 30 over 100 times 12.586 kilogram. And in that case, when you do that correctly, let's take our calculator. 30 over 100 then times 12.586. You're going to get 3.7758 kilogram. So then we are going to add this to this. Are you getting it? So we are going to add the answer we had to it. So we are going to have, so the air will be, the quantity of air will be 12.8586 kilogram plus 3.7758 kilogram of air. So at the end, the answer that we are going to get will be 16.362 kilogram of air. Now let's do the second one, which is the quantity of the volume by volume. With by volume, with by volume, what you know is that volume of air, we know that it will be 100 over 21 brackets open, which will be 32 over 12 times carbon was carbon in this case is 0.9, then plus 8 hydrogen composition is 0.06, 0.06, then minus oxygen was given as 0.01, so 0.01 all over 8, then plus sulfur. What was the sulfur composition? Sulfur was 0.025, 0.025, and then you close the bracket. So in that case, let's do that and see. That will be 100 over 21 bracket open, 32 over 12 times 0.9 plus 8 bracket open, 0.06 minus 0.01 all over 8 close bracket, then plus 0.025 to close bracket, and the answer you're going to get is, the by volume you're going to get 13.79 meter cube. And in that case, 30% excess of air is used, so we are going to also find excess. We are going to also find the 30% of excess air used. So in that case, what you do now is we are going to have 0.3 times 13.79 meter cube, then plus 13.79 meter cube. And when you do that correctly, 0.3 times 13.79, we are going to get we're going to get 4.13. So this will give you 4.137 meter cube plus 13.79 meter cube. So in that case, your answer will be 17.927 meter cube. Thank you very much for this video.